Today I'm going to talk about the mean value theorem and Rolle's theorem. They're very closely related, and in fact they are almost the same. Rolle's theorem just has an extra condition. The mean value theorem states that if a function is continuous on a closed interval, AB, and differentiable on the open interval, AB, that means there's a C in the interval AB such that f of b minus f of a over b minus a equals f prime of c. Really, all this is about is parallel lines. I have a diagram here. If I look at f of b minus f of a over b minus a, that represents the slope of a secant line. F prime of c is the slope of a tangent line. If lines are parallel, that means they have the same slope. So this says the slope of the secant line is equal to the slope of the tangent line. The mean, and I can see here that's where that happens. The mean value theorem just gives us a the mean value theorem just gives us a way to find this value c. Rolle's theorem adds an extra condition. Rolle's theorem says that f of b equals f of a, which basically means the slope of a secant line is 0 because I would get 0 over some number. I picked my a and b to be x-intercepts in this case, so f of a equals f of b, which is 0. That does not always have to be the case. I could have picked an a and a b down here. All that has to happen is f of b and f of a have to be the same, and then there's a value c in that interval where the tangent line is equal to 0. Because if f of b equals f of a, the slope of the secant line is 0. So let's look at an example. For the mean value theorem, if I have f of x equals x squared plus 2x plus 4 on the interval -1, 0. I know this function is continuous and differentiable because it's a parabola. So, because I have a parabola, a polynomial function, I know I've met the conditions. If I try and see what the slope is on the interval -1 to 0. F of -1 is 3, f of 0 is 4. So if I substitute into my slope formula, 3 minus 4 is -1 over -1. So the slope of my secant line is 1. To find the value c guaranteed by the mean value theorem, I'm just going to set the derivative equal to 1. So the derivative is 2x plus 2. Since I'm looking for a value c, I'm going to go ahead and write a c in here. 2c plus 2 equals 1. Then I'm going to solve for c. And my value c, guaranteed by the mean value theorem, is 1/2. If I look at this example for Rolle's theorem, again I've got a polynomial function, so I know the function is continuous and differentiable. It's a 4th degree equation. I'm looking on the interval -2, 2. So the third thing I have to check for Rolle's theorem, after it's continuous and after checking if the function is differentiable, is to see if f of b equals f of a. If I substitute in -2, f of -2 is 8. F of +2 is 8. So since f of -2 equals f of +2, the slope is 0. The conditions of Rolle's theorem are met. So now I'm just going to take the derivative and set it equal to 0. So the derivative is 4x cubed minus 4x. So if I set 4x cubed minus 4x equal to 0, I see that I can factor out 4x, and that leaves me x squared minus 1 in my parentheses. And then, since this is a quadratic, a difference of two squares, I can factor it into x plus 1, x minus 1. And if I set each of these factors equal to 0, I get x equals 0, x equals negative 1, and x equals positive 1. So there's actually three places where Rolle's theorem is satisfied. The only thing I need to do is go back and check to see that all of those are in the interval -2 to 2. And they are. So now those are my three values guaranteed by Rolle.